Welcome back. In this video, we're going to introduce some additional definitions and assumptions that will help us as we continue our studies in geometry. These will be nice for clarifying certain concepts, and these are ideas and concepts that we will continue to use and rely upon for the remainder of our studies. So let us begin with collinearity. Collinear, if points are collinear, these are points that lie on the same line. So col meaning with, linear line. So collinearity means we just have points on the same line or segment. So here we would say points A, B, and C are all collinear because they're 3 points that lie on the same line. Non-collinear, this is an easy one, non-collinear, points that don't lie on the same line. Okay, so we could have a line XY, okay, we might have a point up here called Z, and X, Y, and Z would be considered non-collinear because they don't all lie on the same line. Betweenness. Now, betweenness, in order to say that one point is between two others, all 3 points must lie on the same line. So above here, up here, where it looks like Z is between X and Y, we can't really say that because it's not collinear. Where we can say B is between A and C. The triangle inequality. So a new concept here. The triangle inequality says that the sum of the lengths of any 2 sides of a triangle will always be greater than the length of the third side. So let's say I have a triangle with length sides 5, 12, and 13. So I'll label that 5, 12, and 13. Well, that looks like that would work. The sum of any 2 sides is greater than the third side. 5 plus 13 is greater than 12. 5 plus 12 is greater than 13. 12 plus 13 is greater than 5. So we're good there. Okay. Whereas if I draw another triangle, let's say we had sides of 2, 3, and 8. Well, if we look carefully at this particular triangle doesn't really even make sense because if this is 8 units long and this side is only 2 and this side is 3, how is this 2 plus 3 going to meet? If you think of this angle here as a hinge, this triangle really should it should kind of open flat, shouldn't it? It should fall upon itself. If this side is only 3, it might only go to there, right? This would collapse down there, this would collapse down there. So we'd have 2 units there and 3 units here, and we'd only take up 5 of the 8 lengths. So clearly a 2, 3, 8 triangle doesn't make any sense at all, okay? And sure enough, 2 plus 3 is not greater than the length of the third side. Okay? Or another way to look at this is the third side of the triangle will always be less than the sum of the other 2 sides. Okay? And that's not the case. 8 is more than the sum of 2 plus 3. 13, that's less than the sum of 5 plus 12. 25. Okay, 5 is less than 25, so that does seem to work out as you work your way around. Pick a side, the other 2 sides, the sum of that is going to be greater than that. Or the third side of the triangle is going to be greater than the difference of the other 2 sides. So the difference is that subtraction. You remember that from your algebra days. So greater than the difference, 12 minus 5 is 7. That's 13. So that is greater than 13. Okay. 13 minus 12 is 1. That third side, 5, is more than that difference. Whereas in this one, if I'm greater than the difference, 8 minus 3 is 5. 2 is not greater than 5. So this triangle clearly doesn't work. So we've shown multiple ways the triangle inequality. Less than the sum of the two sides, greater than the difference of the two sides, or just drawing it out, we can see it doesn't make any sense. On to our assumptions. There are things we can and can't assume in geometry. Okay, and we will be able to use this throughout the rest of the year. Okay, so it is okay to assume straight lines and angles. So if a line looks straight, then it's straight. Okay, we're not going to be real sneaky and say, oh, that angle, that's not a straight line. There's a vertex here, and that angle is 179.99 or 179 degrees 59 minutes. We're not going to do that to you. If it looks straight, it's straight. It's okay to assume straight angles. Collinearity of points. Okay, we talked about collinear already. So if points appear to be on the line, they're on the line. We're not going to trick you or change things around on you and say, oh yeah, it looks like A and B are on that line, but they're really not. We're not going to do that to you. It's on the line, appears to be on the line, then it's on the line. Betweenness, if a point appears to be between 2 points, it is. Same thing. Okay, up here, C, as long as it's on the line, is going to be between A and B. And the relative positions of points, if a point is to the left or right of another point, then it is. Okay, we're not going to say that point C here is actually to the left of point A. It's not. Point C is to the right of point A. It's to the left of point B. Okay, it is where it shows it to be. Some things we cannot assume. You cannot assume right angles. Okay, we can assume straight lines and angles, but we can't assume right angles. So that might look like a right angle, but it's not until we put the right angle box in it. Once we put the right angle box in it, then we have a right angle. So now it's right. Before, didn't know. Might have been, but might not have been. So do not assume right angles. Do not assume congruent segments and angles. Okay? So I say follow the tick marks. So if we have two angles, okay, and there are no tick marks, are those angles congruent? We don't know. Can't say. Okay? Now if I do this, they're congruent. Okay? And do not assume the relative sizes of segments and angles. So which angle or segment is larger? So if I had two angles like this, okay, those two angles, I don't know which one's larger, okay? This one could be 78 degrees, and this one could be 14 degrees. Which is the larger, the wider opening angle? Well, the 78 is. Even though it looks like it's wider opening, it's not, because it's only 14 degrees, that one's 78. Same thing with segments, okay? If I draw a segment AB, and I tell you that that's 25 units long, and then I draw this segment XY, and that's 3 units long. Which one of those is bigger? Well, XY is bigger than AB. because this one is 3 and it's smaller. Did I say XY is bigger? XY is smaller than AB. AB is bigger. XY is smaller because it's 3 units versus 25 units, even though it looks like it. So you cannot assume the relative sizes of things. So commit those to memory, get used to using those. We're not going to try and trick you with some of this other stuff on the left-hand side, but be careful not to assume things like right angles and congruent segments and congruent angles. Follow your tick marks, and you can be fooled by sizes. So make sure you look and see what the labels are and follow those labels. So that wraps up our information on this particular section, our definitions and assumptions, and we will see you in class.